Kubernetes 1.28 has been released on 15th of August 2023, and I wanted to create separate set of videos for a few particular features that I'm very excited about. And in this particular video, we'll be going through the new alpha feature of sidecar containers or init containers with restart policy always, which I'll be explaining in detail with demo. So welcome to Cube Simplify. My name is Sayam Pathak, and before getting started, I would like to thank Cisco, Comoros, Sysdig, Slim AI, and Cast AI, that is the newest member. Now, these all orgs support my work so that I can create these videos for you. So make sure to check them out. Links are in the description. So let's get started with the brand new feature of sidecar pods in Kubernetes 1.28, which just got added as an alpha feature. So Kubernetes 1.28, it includes 45 enhancements, out of which 19 are alpha, 14 are beta, and 12 are stable. And I really love the logo. So in order to understand the new feature, first let's try to understand what sidecar means, or maybe what you are used to call it as a sidecar pattern. What was it, and why was there a need to have the sidecar containers as the first class citizen inside Kubernetes? Now, what is a sidecar? So in Kubernetes, obviously there is a concept of pod. Now, a pod can have multiple containers. So sidecar can be treated as a container which sits with your application main container and acts as a helper pod. So you have a main container and then you have a sidecar container. They both will share the same namespace, means they will be able to talk over localhost. Now, there are many use cases. First, let's try to understand the use cases. There has been a very good blog written by Brendan in 2015 where he has explained various sidecar patterns. So one of the most common use cases that you will be seeing sidecars is with the service mesh. So if you are familiar with the concept of service mesh, you definitely know that there is a proxy server that is there attached as a sidecar container, or I should say injected as the sidecar container in the data plane to the pod for different use cases. Now the first pattern can be as the shared file system. Now let's say you have a pod. In that pod, your main application is your web server. In this particular case, let's say it's Nginx, and it has to have a shared file system and has to be in sync with some repository that you have to serve, or maybe a bucket that you have to serve. So you can have a sidecar for that, and you can sync the file system with the repository or the bucket or whatever it is. And you can also have a web server container, a log sidecar container, which will be acting as a log saving sidecar container to the file system. So how this will work? Like, if you want to visualize this in a very simple example, let's say there is an empty directory. So inside a pod, you'll be having a volume. Volume will be empty dir, and then inside each of these containers, you will be having the volume mounts. The volume mount inside the containers will be at the different locations. So you can actually mix and match different things so that you will be able to use the same empty dir, which is the same volume for both the containers. So that is one of the use cases over here. The next pattern is the ambassador container pattern, which is also a sidecar. But here what happens is, let's say you have a main container and you have a proxy container. Now in this particular scenario, consider it as a very, regular example. You have main container and you have a database application, let's say Redis, and you want to connect to the database. Now you can connect to a different database, or you can connect to a highly available database that has multiple reads or single write, or you can have it as a highly available setup. So you want to connect to a particular healthy database over there, like healthy instance over there. So what you can do on different environment. So what you can do is you can leave the main container as it is and rest of the logic in the proxy container. So for example, the ambassador container can listen to the main container over the local host, and then it will be responsible for connecting to the Redis server as defined in its configuration. The next one is the adapter container. So adapter container is also kind of a sidecar container with a reverse proxy, where it gathers the metrics, where it acts as a metrics collector. So very typical example would be like you have a particular agent that is just collecting the metrics from the main container and then pushing that metrics to a centralized monitoring system like Prometheus. And since these can communicate over local host, so you should be able to exec into this particular pod and see the /metrics endpoint from the pod. So these are the common patterns the sidecar containers shared file system pattern, the ambassador pattern, and the adapter pattern that have been very famous and very widely used since the inception of Kubernetes, since Kubernetes have been growing. Since that time itself, these have been in use. Now let's try to understand in a different way. Like we are still trying to understand sidecar containers, but now we'll try to understand sidecar containers in a different manner. So let's say you have a service A and you want to communicate. You have a pod A and you want to communicate with the pod B, and you have a pod A and you want to communicate with pod C. So in this particular case, you will be having a separate logic for each of the pod within your application itself. Now, what you can do is, and also you need to manage different set of things. Like you might want to have authentication or mutual TLS, and then you also might want to have expose metrics just like here, and you might want to trace these calls. You might want to have health checks for each of these. So they cannot be hard coded, or they cannot be done differently, or it is very tedious to do differently for all the containers. So what you will be doing is you will be having a sidecar container. Like in the service mesh world, we call that a sidecar proxy, which is responsible for authentication, mutual TLS, health checks, tracing, metrics, all those kind of things. So you as a user are running your application. So you as a user are running your application in Kubernetes as pods. That's how your application runs. Now in your Kubernetes pod, you are having a main container A and then a sidecar container. Now when the request goes in for your application, it goes from the user to the sidecar container, and then it is authenticated, MTLS, all that stuff is managed. And the main container, it goes to the main container, talks to it over localhost, it performs whatever task the main container is supposed to perform, and then it again goes back to the sidecar container if it has to talk to the service B or the pod B, and then the side request goes from this particular pod's sidecar container to the another sidecar container of the main container B, and then it is able to communicate via this way. All the traces are collected, metrics is there, health checks will be there, and you will be able to track everything from this particular container. So you will be getting all the information. Now everything is going fine. What is the problem? Till Kubernetes 1.28, there was no native support for the sidecar containers. It's just basically a multi-container pod. So it's fancy. Like these are just the patterns. These are just the sidecar patterns, but it is nothing like sidecar containers. It is just multi-container pod. That's what it is. It's just a multi-container pod. So what's the problem? So problem is we don't know the sequence when which container will start. Although there is one concept of init container. Now init containers definitely starts, like you have 1, 2, 3 init containers. They will run first one, then second, then three, then all three. After all three, there will be the fourth container, the main container which is running. It doesn't solve the sidecar pattern. Here definitely we can schedule certain pattern or the certain order for the containers to start until the main container, but it doesn't solve the sidecar pattern because that container has to run if it has to collect logs, if it has to collect metrics, if it has to live till the execution of the pod, just to make sure nothing goes wrong. Now in sidecar, for example, you have again multi-container pod where you are running a job, and now you are running a job. So you are a user, you are running a Kubernetes job, and you have container C1 and C2, where C1 is the main container, C2 is the sidecar container. Now C1 completes exit, but C2 is a support functionality, and C2 has not ended yet due to some reason, so the job never ends. It becomes a failure over there. Another problem with sidecar container is log forwarding and metrics, the adapter pattern that we have seen. So you have container C1 and you have container C2. C2 is your sidecar and C2 is collecting metrics from here. But what if C1 starts first and C2 starts later? Like your log collector or metrics collector is not even ready, and it's a very short-lived pod, and your main container just starts and fails, and you are not even able to capture that particular metrics. So what if the logging container starts after the main container? So you have your main container that has started, that has executed or went into error, crash to backup or whatever it is, and your logging container is started later on after this particular error. Then what will you do? You won't be able to capture the particular error that you intended to at first place when you're putting this sidecar. because you were not able to define any sequence, because there is no concept where you can define sequence for multi-container pods. So logs starting after the main container, and logs container didn't start and the main container crashed. Now these two can be very tricky scenarios over here. In service mesh world, now service mesh has been widely used. People have been using service mesh for years now, obviously for complex use cases. But you have service mesh, you have proxy starting, termination, similar to above issue, like proxy starting, when it is starting, and when it is terminating, it should terminate with the pod lifecycle. If it's not terminated, it will be an issue. So service mesh have created various workarounds to make it work, but obviously workarounds are hard to manage, and it would have been good if this was a first-class Kubernetes citizen and handled at the Kubernetes layer itself. Also, problem with config maps and secrets, as mentioned in the KEP, some pods use init containers to pull down the configuration and the secrets and then update before the main container starts, but then use sidecar containers to continue watch for the changes and push it to the main containers. This requires two coding paths as of today, and the same sidecar container could have been used. So these are some of the problems that have been listed again in the same KEP, which is there for the sidecar container to make it work as a native Kubernetes citizen. Now, the problems have been since 2000, I think 15, 16 timeframe. If you look at Kubernetes issues, you'll be able to find the topmost issues with respect to sidecars listed over there. And then proposal for this was started in 2019. And now in 2023, we have finally in Kubernetes 1.28 init containers with restart policy always. So sidecar pattern, first class citizen inside the pods, and the restart policy is optional. So if it's not there, then it's treated as a regular init container, else it is a sidecar container. So the container restart if it's exit, and since it is also an init container, so you can specify the sequence. So it will run in sequence. So you can exactly specify when the sidecar container should run, like you need some processing to be done before the sidecar, some processing to be done after the sidecar, and then the main container. You should be able to do that because the next set of init containers will start after the startup probe success of previous container and not the exit wait. So previously, like if it was exiting and next init container will start, now only the startup probe is success, and then next will start if the restart policy is set to always, and then init container resources being added to the main containers when it is set to always. So again, this is where I have tried to explain, like you have 1, 2, 3, and 4. So you have 4 init containers that are running sequentially, and you can make sure that this one is your sidecar container with the restart policy always, and these are pre-sidecar, that some configuration you need to do before the sidecar starts, and then you want to start, and then you want to do another sidecar or another job, and then you want to start the main container, and this one is with the restart policy always. This will always be running, and this will run and exit, and then the main container, and this will keep running until the main container job is executed. So this makes it easy when to start sidecar container, same as the pod lifecycle. Restart on OOM memory. So if you have like OOM timeouts and stuff, it will be restarted because of the restart policy always, and other issues makes it more reliable to use. So I hope you get a gist of what sidecar container was, like what were the different patterns. So patterns will remain the same, like you will be wanting to use in the similar set of use cases. Then what were the problems? Some of the workarounds that the service mesh community was having. Now with the init container always, like with the init restart policy, init container restart policy always, we will be able to solve most of those problems. And then with the community feedback and a few iterations, this will go to the next level, and people will be using sidecar more frequently. Let's try to do a demo real quick for this. In sidecar containers is an alpha feature, so this has to be enabled via the feature gates. And in this particular demo, I'll be using kind cluster. Pretty simple. You can use any scenario, any 1.28 cluster, my Kubernetes scenario, edit the etc Kubernetes API server YAML file, and then also enable the feature gates, and you should be able to do the same demo. So let's create the config file. So in this, we are saying we want to create a cluster with feature gate sidecar containers true. Now let's create the cluster. So it's very simple. Kind create cluster. Name is QSimplify. an image kind set node v1.28.0 hyphen config as sidecar config. It will take some time, download the image and create the cluster. So you can see the cluster is up and running, and let's try to do kubectl get nodes. Kubectl get nodes, and you can see the control plane is up and running. Now let's actually try to run a particular pod. So this is a deployment, simple example which is there to run sidecar containers with the new restart policy always. So this is the normal regular Alpine container that is putting the logs in this particular folder, and they both are having a shared file system. One of the first use cases that I told about the sidecar pattern, but in this particular case, you can see the restart policy is always. So let's try to deploy this. Created. Pods are getting created. So it's init 01 pod initializing, and pod is running. Now since the pod is running, we can actually exec into the pod. So kubectl exec -it -sh, and let's do tails -f/opt logs.txt, and you can see the logs are coming in. So that's one use case. Another one can be the job one, which is a very common one. Let's try to create a job via job.yaml, but we will do this later. First, let's run without the restart policy always and as a regular container. So kubectl apply -f job and kubectl get pods. And you can see the init container is just running. It's a regular init container, and we are not, like, the job is even not terminating. Even if I put it as sidecar container, means not putting it as an init container. So if I just do this and do kubectl delete -f job, and then again create it. So after creating this job, if I do kubectl get pods, I will be able to see that it's not ready and it's not completing and it's not working as a sidecar container. So I'll delete the job, and now with the new feature, we will enable it as a sidecar container with restart policy always. And now we'll apply job and we'll do kubectl get pods, and in some time the job status will get completed. So this way you can see the issue of jobs not getting completed or staying in limbo for a long period of time is not there, and jobs are getting completed. So I showed you a couple of scenarios where you can easily use the new init container all restart policy always and how it is helping and behaving like a sidecar, catering to all the patterns that we discussed earlier with no problems that I discussed earlier. So that's all about the Kubernetes 1.28 sidecar feature. I hope you understood and got the gist of what sidecar patterns are, what are different types of sidecar patterns, what we used to do before, what were some of the problems when all this started, and now where are we with this Kubernetes 1.28 alpha feature and how you can try the same. So make sure to check out Kubernetes documentation for 1.28 and subscribe to this particular YouTube channel, because I'll be covering some other features as well with Kubernetes 1.28. Thank you so much for watching. Share this video if you want other people to know about the new sidecar sidecar containers feature in Kubernetes 1.28 that came in out as alpha feature a couple of days back. Thank you so much for watching. And just before going, make sure to check out Cisco, Commodore, Sysdig, Slim AI, and Cast AI. Links are in the description. The more you check them, they'll keep supporting me and I'll be able to keep producing the same content that I have been producing. Thank you so much for watching and see you in the next video.